Let's get started. All right, so we are going to talk about 4.3, adding and subtracting rational expressions. And just to make sure everybody is understanding, what a rational expression is, like rational numbers are numbers that can be written as fractions. And so rational expressions basically just means that we're going to be dealing with fractions all the way through it. And so if you've looked at some of those videos so far, you kind of see that that is the case. And so the whole module, we're going to be dealing with fractions. So if you haven't made fractions your friend yet, this would be the time to do it because it's going to be really good to make sure you're there. Okay, so I'm going to do this first example where we have the same denominator. And so remember, when we're adding and subtracting fractions, you must get a common denominator. All right, so I'm going to write that in here. All right, so must get a common denominator. So that is super important. When we're multiplying and dividing, we don't need a common denominator. And so that's kind of what makes the Oh, am I not sharing my screen? Oh my goodness. Just 1 second. Oh yeah, just feel free to make sure that I am. Let's see, is that better? Okay, let me move.
Yes, it is.
Nice. Okay, so we've got to get a common denominator with adding and subtracting, but we don't with multiplying and dividing. So that's why the multiply and divide ones tend to be a little bit easier to do, I think. But these ones where the denominator is the same, those definitely are easier as well because you don't have to get a common denominator. But the first thing that you're going to want to do is you're going to want to make sure that on this that you factor the denominators. Okay, so I'm going to go ahead and start by doing that. And so I can see here, if I factor this, I'm thinking what multiplies, so we've got y and y, but what multiplies to be -2 that adds to be 1. So I know it's got to be 2 and 1, and in order for it to be a positive 1 in the middle, I'm going to have a +2 and a -1. All right, and these both factor to be the same thing. And so that makes this a little bit easier to deal with. However, there is something that I want to caution you about, and I'm going to put this in parentheses here, because when we're dealing with this subtract sign in between it, it really is something that we need to think of as, I like to think of it as like change this to add and then put a -1 here, because you're subtracting both the y and the -3. And so essentially what we're doing is we're distributing a -1. We've just got to change the signs of everything when we subtract that whole thing. If there were 3 terms on the top, we'd need to distribute that negative to all 3 terms. Okay? And that's probably the part that gets missed a lot of times. Okay, so let's look at this. So let's see what we have here. So on the top, we're going to have 2y minus 1. And then remember, we're going to distribute that -1. So I'm going to have -y plus 3. And so oftentimes it's that last part right there, that plus 3. A lot of times students leave it as that minus 3 because they forget they've got to give both of the signs there. And then we have a common denominator already, so I'm going to go ahead and write that common denominator here that we found. So in one parenthesis, y plus 2, and in the other parenthesis, y minus 1. And now let's go ahead and combine our like terms together. So when we're adding and subtracting, basically, we're combining like terms in the numerator. So 2y minus y is just going to be y. And then I've got negative 1 plus 3 is a positive 2. And then that's all over that same thing that we had before, y plus 2 times y minus 1. And then at this point, we can see that we have a common factor. So be really careful, because I can't just divide out like this y with this y, because they're connected by addition or subtraction. All right, remember, we can only do that if things are connected by multiplication. So I'm connected by multiplication here, so as long as I have one whole term or the other that can divide out, then I can divide those out. So I have the y plus 2 on the bottom that divides out with the y plus 2 on the top. And so then I'm just left with 1 on the top. Because remember, I divided these out. Anything divided by itself is 1, so we leave that 1 on the top, and then y minus 1 on the bottom. And again, be really careful. You cannot divide out if something is connected with add and subtract. And that's going to be really tempting to want to do, but you can't do that. Only with multiply and divide. So when things are all connected by multiplication, that's when we do that. All right, so like I said, when the denominator's the same, it's not so bad, right? But we're going to get into talking about what happens when the denominator is not the same. So I want to start off with just some like adding fractions before we put some variables in there. So say that I want to add 5/12 to 3/8. Well, the first thing I need to do is factor the denominator, kind of like how we did down here. But when we factor these, we're doing our prime factorization. So we're making these little factor trees, right, to help us get these factored. So 3 times 4 is 12, and then 4 breaks down to be 2 times 2. 2 times 4 is 8. 4 breaks down to be 2 times 2. So I'm going to rewrite these with the factored denominator. Okay, so I still have 5 on the top here, but instead of writing 12, I'm going to write it as, I'm going to write it just, it doesn't matter the order you put it in, but I'm going to write it as 2 times 2 times 3, just because I like to put them in order if I can. And then on the other one, right, 3 is on the top, and then I've got 2 times 2 times 2 on the bottom. Okay, so this is how we're going to find these LCDs. What we're going to do is we're going to look at our denominators and try and figure out what factor or factors are missing in that denominator that the other one has. So what I mean by that, so let's look at this one here, right? So when I'm trying to figure out my LCD, write it up here, it has to be everything that both of them have in common. So this first one has that 2 times 2 times 3. So I know that's going to be part of my LCD. Okay, however, if I look at my other denominator, notice that there are 3 2's there, not just 2 2's. So that means I need to multiply this by another 2, okay, in order to get there. So if I do that, so this one needs to be multiplied by another 2. So let me put 2 here. But if I multiply 2 on the bottom, I also need to multiply by 2 on the top. All right, now let's take a look at the other denominator. Here I have 2 times 2 times 2. And what did this denominator have that our denominator here needs? Well, it needs a 3 so that it can look like this LCD we have up here. So let's multiply this by 3. And if I multiply by 3 on the bottom, I need to multiply by 3 on the top. Okay, so questions up to that point? Are you with me? And I'm doing this in a very specific way. Some of you might be going, that looks kind of different than the way I would do it. But there's a reason why, and it's because it's going to kind of match what we're going to be doing in our next problems. So that's why I want to make sure that you have that. All right, so let's look at this. So now I know that I have my LCD. All right, and so on the top here, 2 times 5 is 10. And then on the bottom, 2 times 2 times 2 is 8, times 3 is 24. All right, and then my other fraction, 3 times 3 is 9. And then again, we should have the same thing here on the bottom, right? 2 times 2 times 2 times 3, it gives me that 24 again. And now I can just add those numerators together and we leave the denominator the same. So we get 19 over 24. Now, if there was a common factor, we'd want to make sure that we reduce that fraction, but there's not. 19 is a prime number. So in order for there to be anything, we'd have to, 24 would have to divide into 19, which it doesn't. So we are done at that point. Okay, so notice how what I was doing, I was looking for what each part was missing that made my LCD. Okay, and that's what I want to go to when we're working through some of these where we need these common denominators here. Well, before we do that, let's just look at these two. Let's spend some time making sure everybody's good with finding the least common denominator. So again, we need to factor the denominators so that we have these. So what does this m squared minus 16 factor to be?
M minus 4 and m plus 4.
Yeah, right? That's a difference of squares. So we can factor it to be m minus 4 times m plus 4. How about this one? How does this one factor? So we know we got m and m, right? Because that m squared, so what multiplies to be 16, that adds to be 8.
Plus 4 on each one.
Yeah, plus 4 on each one. Okay, so now let's look at finding the LCD of this. Okay, so here, my LCD. So we know that we're going to have, right, I just look at one of my denominators and I say, okay, everything that's there has to be part of my denominator. So I'm going to just look at that first one and have m minus 4 times m plus 4. Okay. And so when I'm looking at my other denominator, I notice that I have 2 m plus 4s. All right, but over here I don't have 2 m plus 4s. So that means I need to make, so I need another m plus 4 to make this my LCD. So let's look at this again. So if I'm thinking about what is this denominator missing that this one has? Well, it needs another m plus 4. And what about this second one? What is this second denominator missing that the first one has?
M minus 4.
Yeah, m minus 4. All right, and then I can see I have exactly the same thing there. And if I was adding and subtracting it, right, I would make sure that whatever I multiplied by the bottom, I also multiply by the top. But on this one, it's not asking you to add them together. It's just asking to find the least common denominator. All right, questions on that? On how to do that?
So when the homework
Mm-hmm.
has to enter the answer,
Yeah, just make sure if it's asking for the LCD, you just want to put m minus 4 in parentheses, m plus 4 in parentheses, and then another m plus 4 in parentheses.
so because the m plus 4 is 3 times.
Well, it repeated here, right? There was 2 of them on this side. So that means I need 2 of them in my denominator. Because that was all one part of one fraction.
Okay.
Right.
Don't I need to, when I enter the response, don't I need to enter in the denominator, the first denominator, the other m plus 4? Because it's m minus 4 and m plus 4.
Yeah, so we need to multiply it by another m plus 4 so that this one has 2 m plus 4s. Because this side has 2 m plus 4s. Just like we had up here, right? Like think about with these numbers, because sometimes it's easier with the numbers. We had a lot of 2s, right? Mm-hmm. And so it's just a repeated factor. So this one had 2 2s, but our other fraction had 3 2s, so we had to make sure that this one has 3 2s.
So both of them have to be exactly the same.
Yeah.
But when I enter the response, I still will enter the 2 positive that go from, oh no, I'm dividing it on my mind. Never mind. I clicked.
You got it? Okay. No, that's good. Yeah. Sometimes it just takes a minute to get it, so no worries. Okay, and on this other one, let's look at this one as well. So I want to make sure that you see that sometimes when you're factoring the denominator, sometimes all you can do is take out a greatest common factor. And remember, that's the first thing that you should always try to look for first when you're doing some factoring. Because it's going to make the rest of the factoring easier. So on problem 4, on this first fraction, do you see I have 2 is a greatest common factor, right, of 2y and 6. So I'm going to factor that out, and that's going to leave me y plus 3. Okay, what about on y squared minus 9? I'm going to do it in a different color, maybe. How does this one factor? Well, it's a difference of squares, so we're going to have y plus 3 and y minus 3. And then that last one that I have, let's see, I'll have to put it in purple, is just y. All right? So I'm trying to put these different colors just to make sure that we're all together on it, right? And we want to make sure every single denominator has all of those factors, all the factors in common that they need. So if I'm figuring out my LCD here, I'm going to choose to start with that second fraction. It doesn't matter where you decide, where you start. You just need to look at one of them. I just want to make sure you see that you could do this like in a different order and still get there. So I need to have a y plus 3 times a y minus 3 as part of my LCD because that's what this denominator is. Okay, now let's look at this one in blue. So what do I need to add to my LCD that doesn't already show up there? So I have a y plus 3 already. All right, so I don't need to write that y plus 3 down again because I don't have two y plus 3's anywhere in this. That's why I put them in different colors so you can see we're thinking of these as three different things. So I need a 2.
So did you add the 2?
I need a 2 because that is part of what I need. And then I also need to...
But you also need a y, right?
Yeah, we also need a y. Right? So does that make sense? And so that whole thing together is our LCD. So we're just kind of looking to make sure that every part gets what it's missing, right? So this one would have to be multiplied by y, and then y minus 3. This one needs to be multiplied by 2y, and then this needs to be multiplied by 2 times y plus 3 times y minus 3. So they all look like this. That's how our denominators all need to look before we start adding or subtracting. Okay. All right, let's try it with some problems here. I'm gonna go, let's see, I want to make sure that I thought I had some other ones that were, all right, yeah, so let's look at problem 6. So problem 6, all right, let's first of all try and figure out what is our LCD. So what needs to be part of it? Tell me one part of that LCD, one of the factors.
Right. But and 1.
So this whole thing is together. I can't separate that out and I can't separate that out, right? But those are my factors that I need. So yeah, so I'm in one parenthesis, I'll have r minus 2, and then my other factor needs to be r minus 1. Excuse me. Okay, let me just get rid of this so I don't. All right, so if that is what my denominator needs to look like, let's rewrite this out and see what it is that I am missing. Okay, so let's see. Sometimes it's helpful if I have it in a different color here. So I'm going to put it, I'm just going to kind of rewrite what I have here. So 2 over r minus 2. And then minus r plus 3 over r minus 1. Okay, so looking at this, what factor is this first denominator missing that we see is in our LCD?
The r minus 1.
Yeah, so we're going to multiply the bottom by r minus 1, which means we need to multiply the top by r minus 1. Okay, how about this second fraction? What's missing here?
The r minus 2.
Mm-hmm. So if we multiply it on the bottom, we'll also multiply it on the top. And let's put this in parentheses here because that whole thing is together and we want to make sure that we're keeping it together. And then also notice there's this negative sign there, right? So, or this subtraction. And so we're going to have to subtract that. So I'm actually going to put another, just these little kind of braces around it. So I remember that, oh yeah, I've got to distribute this -1 also. So when I'm working on the top here, do you see on this first one, I just need to distribute that 2 to both of them. But on this second one, I'm going to have to FOIL and then distribute the -1 through to everybody. Okay. So let's do that. So now my denominator, I have my common denominator, right? So I'm just going to write this down as kind of one big fraction here, where I've got r minus 1 times r minus 2 on the bottom. And then let's see what we have here on the top. So let's distribute these through. 2 times r is 2r. 2 times -1 is -2. Okay, then I need to FOIL these together. I'm going to just do that right above here. So I've got r squared and then minus 2r plus 3r minus 6. And then remember, I've got to distribute that negative through to everybody here. So let's see. I just change this to red again and just kind of show we're going to distribute that to everybody there. Okay, so when I do that, I'm going to have negative r squared plus 2r, because remember I'm multiplying that by a negative, and minus 3r, and plus 6. So that is the easiest place to make mistakes, is just with those, you know, with that negative and stuff. Okay, but now let's get our like terms together on this so we can see what we have here, because we haven't done any adding and subtracting until we combine these like terms together. So I like to put things in descending order. So I like to start with the highest exponent, which is this r squared, and there's a negative r squared, so I need to make sure that I put that with the r squared, so negative r squared. Now let's combine our r's together. So 2r plus 2r is 4r, minus 3r is just an r, so plus r. And now negative 2 plus 6 is a positive 4. And again, it's all over that r minus 1 times r minus 2. Okay, now the last step that you need to do after you combine your like terms, now you want to look and see if that numerator will factor, because we want to see if it will cancel out with one of the denominator factors. But if I look at this, you know, when I'm thinking about what multiplies to be 4 that adds to be 1, well, 4 times 1 is 4, but there's no way I could add or subtract those to end up with a 1. 2 times 2 is 4, but again, there's no way that I could add or subtract those to end up with a 1. So that means that this numerator won't factor anymore, and so this would be our answer. But you've got to look and see if it does factor, because oftentimes it will divide out with one of the denominator factors. All right, questions on that I can help you with?
So far, so good for me.
Okay. So on this next one, the only thing that I want to caution you on is just that notice how these two are not exactly the same. This one is not in descending order, and I tell you that it will be easiest if you always make sure that you put those in descending order. So I'm going to change this to be negative r plus 3. And then when I look at it, I can say, oh yeah, that's not the same as x minus 3. I've got negative x plus 3. However, they look really close to each other, and I can see, oh, my leading term is negative. So what happens if I factor a negative 1 out of that? What would I be left with? X minus 3, right? If I do negative x divided by 1 gives me x. 3 divided by negative 1 gives me negative 3. All right, so I'm just going to put some lines through this because this is kind of like what we're looking at to try and do, but this is really my denominator, my factor denominator that I want to look at. And so if I take a look at this one and compare it with the first one, what is the first one missing that the second one has?
The negative 1.
Yeah, so I need to multiply the denominator here by -1, so that means I need to also multiply the top by -1. Okay. So when I do that, I'll have 2 times -1 is -2 plus 1. And then on the bottom, my common denominator that I found was -1 times x minus 3. And now let's simplify the top. Remember, I haven't added and subtracted unless I combine those like terms together. So that's what I'm doing here. And I get -1. -2 plus 1 is -1. And then all over this. So is there a common factor I can divide out? Those -1s are both the same, right? So I can divide those out. And so that's going to leave me with 1 on the top and then x minus 3 on the bottom. And so that would be the final answer on that one. So just watch really closely. There will be some on the homework that look like they're the same denominator, but they're just off by a negative. And so this is kind of the best way to handle those type. Okay. Alrighty.
Wait.
Oh.
So if you divided out that 1, how come we still have a 1?
Well, what if we did a 2 divided by a 2? What would we be left with?
Oh, we have a 1.
Mm-hmm. Anything divided by itself is just 1.
Oh, that's right. Okay, thanks.
Yeah. So
I was
that,
just confused.
yeah, I know. With that one, it's kind of weird because, like, it's, you know, when we see a different number, we're like, yeah, but yeah, anytime we have that is, you know, good. Okay, good. Thank you for that question. All right.